Good morning, good afternoon, good evening, good day to everyone around the world, no matter where you're tuning in from. My name is Josh Epstein. I'm the Chief Marketing Officer with Aris Corporation. It's my pleasure to be hosting this discussion today, or really presenting our speaker. This is part of our Pulling the Digital Thread series, where we explore trending topics and technologies that are shaping digital engineering, digital manufacturing, product lifecycle management, and the broader digital enterprise. We're streaming on a delay today to make sure we get a good quality production. So there's no live chat, but we do encourage you to join in on the conversation online on LinkedIn. So if you want to make a post and use the hashtag pulling the digital thread, we'll be watching it. Our speaker today will be watching it, and we'll have a conversation on LinkedIn. So with that, let's dig in. I'm pleased to introduce George Lowry, Vice President and Principal Analyst with Forrester. The topic of conversation today is scaling of variety. So, we live in a really interesting time in terms of mass personalization of products and of really rethinking how products are brought to market. Now that is phenomenal from a consumer standpoint and from a customer experience standpoint. But it definitely poses challenges from a data, from a digital thread, from a PLM standpoint. So George asked George to come in today, speak to some of his research on the subject, and talk about how this mass customization, mass personalization, or I like the term really scaling of variety, is impacting the modern manufacturer. So with that, George, please take it away and welcome.
Thanks, Josh, so much for the introduction, and thanks everyone for giving me the opportunity to share some research that we've been doing at Forrester into a pivot that's taking place in manufacturing from a world really of economies of scale to a world of economies of scope. So I've pulled this material from some research that we've got, and I've got links in the deck. I hope you'll get the deck and you'll be able to look at that research if it's interesting to you. What we're going to do in this short session is to look at the role of digital twins and PLM and agile manufacturing as kind of foundation technologies for mass customization. We'll look at how I just mentioned the idea of this kind of mass manufacturing is now yielding to mass customization. We'll look at the case for variety. Why do manufacturers have to do this? Why is it important to them? And we'll look at some of the challenges that our clients have had, and I'm sure probably you're seeing as well. And then we'll look at the role of some technologies in resolving them. And in particular, one thing that our clients are interested in is how do they build a foundation really for product line engineering. So we'll finish with looking at some of that. Well, just to introduce the idea, I think this is very familiar and probably obvious to everyone, is that we've come from a manufacturing age where you could have anything you liked as long as it was black. And the point was really to try and make the same thing over and over again as cheaply as possible and to mass manufacture the same thing. But now we're living in a different world, a world of variety. And Amazon, of course, has led this. So we've seen a pivot from a world of mass manufacturing and mass marketing, the age, if you like, of the madmen, to now a world where Amazon has led the way, particularly in the B2C world, of being able to serve a long tail. So very much smaller segments, but with very much more targeted products. And manufacturers are doing exactly the same thing. Think about the vast proliferation or variety of manufactured vehicles that there are, and the fact that people really want to have their choice rather than, let's say, always having the same thing. So let's think a little bit about the case for scaling variety. Part of it's about market fragmentation. I just kind of touched on that. Part of it's about a proliferation of features and options, an explosion of product and model variants, and some of it's about a rapid rate of product introduction. We'll look at some data on that. And all of that is compounding supply chain and production complexity. Now, you can just think about anything in the kind of industrial world, the number of variants and options, the level of configure to order, even engineer to order. So you can look at this gas turbine here, and you could have a gas turbine for many different types of applications. You might have a special one for, I don't know, maybe a naval vessel, or perhaps even a racing car, and it would be different. And at the same time, we see this in the B2C world. So every single thing that has a barcode, you can see this kind of example here from a retailer's shelf. Everything with a barcode has a set of characteristics that define it. And to get that barcode, you have to declare the characteristics to the GS1 organization. Interestingly, we looked at the number of GS1 barcodes that were in existence. In 2021, there were 100 million. In 2023, there were over a billion. So you can see a massive proliferation of different types of items. Why is that? Because the manufacturers are trying to find something that's sticky, that is really relevant to specific audiences rather than a general or mass audience. And manufacturers have been working at this for a long time. So if you look at something like yeah, a high-end motorcycle like a Harley Davidson has thousands of features and options. And Harley early on figured out that it didn't make sense to try and compete just on price. And they allow you to configure your own motorcycle and effectively to see it being created. So they let you know at each stage that, for example, they've selected your forks or your handlebars, and you can see your own vehicle being born. And effectively, that's going to be much more valuable to you than anything that you might get as an import, a standardized import. So that kind of thing has been going on, I suppose, for a few years. Manufacturers have realized how important it is. But doing that is hard. Balancing the cost, the complexity, and that kind of customization is very, very difficult. So Audi have a similar kind of approach, enabling you to build your own Audi. But one of the things that they've had to encourage their customers is to be incredibly patient, because there's a long lead time on this kind of complexity, and so that it has high value, but there's a point at which the cost, the complexity, and the lead time begin to erode the value. And of course, all of this is taking place in the context of changes around sourcing. Don't need to say anything about tariffs perhaps this week, but we've been in a world of economy of scale, which has all about the lowest unit cost. That may not be the case anymore when we're thinking about lead time, when we're thinking about a multipolar world. So we're seeing many of the manufacturers that we work with think about, yeah, rebalancing what's offshore, what's onshore, and what's nearshore. And all of that then means different types of production, potentially different methods of production, different technologies, perhaps different bills of materials in different geographies, and quite a lot of complexity around the bill of material itself. It used to be very flat. Now it's not so flat because we've got technical characteristics which determine what kind of combinations of features and options we can have. So all of that is driving a massive challenge around sourcing and production. Now, we're also seeing companies start to streamline the options, consolidate vendors, and even eliminate parts. Elon Musk himself says the best part is no part. And we have a lot of conversations with our clients about why do we need the parts that we have. So this consolidation is going on, and part of it is also saying maybe we don't need to offer all those features and options, but we need a lot of intelligence and data to determine which we should and which we should not offer. I think probably in 2021, BMW had a kind of a program of, they called it a cost reduction program, but it was really about removing some of the features and options that were too costly relative to their value, or added unacceptable lead time to the orders for people eager for their new vehicle. So we've seen some of this kind of thing going on. The interesting thing, though, is that if you do it correctly, it doesn't detract from your, let's say, your your value or your attractiveness to your customers. So periodically, we do these kind of surveys about the customer loyalty of auto manufacturers. This case in Germany, you can see despite those changes that BMW was able to retain its loyalty. Why? Because it had invested very heavily, particularly in PLM, but also in manufacturing, to try and understand what was really of value relative to cost and complexity and what was not. Now, we're seeing lots of emerging technologies being used to try and unlock, I would say, opportunities to make things in a different way. So, of course, 3D printing, we've done lots of work around that, distributed computing, ubiquitous sensing, so IoT everywhere. And a very important element of this is the digital twin of the products themselves, but also the assets too. Remember, I talked about we might be making things using different methods as well as perhaps different bills and different routings or routings, a different bill of process in different locations as we onshore or reshore, I should say, and rightshore. Fundamental technology to all of this is PLM. Why? Because PLM is the digital representation, certainly of the parts and the products, but potentially of other elements as well, maybe of process and plant as well. And the real critical thing to this is to be able to have invested sufficiently to be able to support the digital transformation as your company pivots from producing the same thing over and over again to producing smaller batches which are targeted at very specific markets to whom you can with whom you can generate much greater loyalty and ultimately much greater uh, margin and lifetime value. Part of doing this is the ability to change PLM from its traditional, I would say, um, document orientation to an orientation around data. And for each of those elements of data to be manipulable and to have its own permissioning and its own security so that you can share it with other people within your own company, maybe with other companies as well. And when we think about this, the pivot from economies of scale, excuse me a moment, from economies of scale in which you have really you have very generalized data. So you've got data around work center, which is an aggregate of the machines in the work center. It has very low granularity, it has a low reset cadence, and it's really basically descriptive. It's not being used for anything. The same thing for the routing or the bill of process, and to some extent for the bill of material. When you come to really detailed stuff like the machine itself or the operator, generally speaking, in the economies of scale world, it doesn't make any difference. It's okay to do that on a spreadsheet and for the supervisor to manage it because it's not really going to have a significant impact on what you can produce, on the promise date for the person who wants that very special motorcycle or that very special automobile. But when you move to economies of scope, you've got a different, really a different way of looking at these applications. So when you think about PLM, it has to be much more granular. Remember, we talked about this bill of material and the bill of material that's got to have a digital thread running through it from as designed to as manufactured with multiple different variants to as maintained. And think about a vehicle that might have perhaps embedded software, might have an over-the-air update that might be different from week to week. So the granularity is very high there. Also, the reset cadence. And it's no longer just descriptive, it's now predictive data. It's data that is used as part of our scheduling, part of our relationship with the customer, part of our customer promise, part of our use of our resources and our people. So you can see that there's a big difference there in uh, in the way in which foundation data is managed. Another aspect of this that really enables this kind of pivot from mass manufacturing to mass customization is the maturity of digital twins. So in the past, they've been really quite simple. They're becoming now much more sophisticated and incorporating multiple different assets and being able to give real-time production insights, but also perhaps real-time insights on usage. So when I'm using a vehicle which has got software embedded, it'll be possible to see when do I use it with the sport and when do I use it with the, I don't know, safety setting. And you see this already with things like aircraft and aircraft engines continually reporting their status and enabling different business models, by the way. So a model which might be a consumption model. So I've worked with people even in things as humble as refrigerators where they're thinking about consumption models. Shall I turn on the extra ice when I have a party? That kind of thing. So all of that really is driving a, a different kind of architecture. So using AI and smart manufacturing to scale customization, it enables you to develop a different type of way of thinking about your manufacturing operations. So in the past, where it was all a bunch of averages, we were using ERP to produce, let's say, rough cut capacity planning, then maybe perhaps using some kind of APS to do the scheduling, but probably mostly using the supervisor and a spreadsheet. Now we're in a completely different situation. We're able to take these applications, particularly PLM, at the core of it, and to join it up to sales applications, perhaps CRM, perhaps Salesforce automation, to be able to configure an order, and then to be able to see actually how are we going to match that to our capacity. How are we going to run it? How are we going to get the right work instructions for each of these different things via MES to people on the floor? How are we going to help them to assemble or to machine or manufacture this very specific thing correctly? And how are we going to fit all these jobs together so that we use the skilled people we have and the materials and the plant in the most effective way we can, keeping our promise to our customers? So we're seeing lots of people using an AI-enabled single pane of glass over these types of applications. So taking their orders and managing them across the execution. Not to mention, of course, the data that they're pulling from PLM and recording back in PLM as the variants that they manufactured. But increasingly now, creating a kind of framework where these applications share data, and that magical digital thread that Josh talked about at the beginning is running through not just design, so engineering technology, but also information technology, so the options that we offer customers, and operational technology. How do we set and reset the machines? How do we provide the right instructions to the operators? So that kind of thing is leading to a different type of agile manufacturing. And one of the things that we're seeing people do is to restructure their supply chain to support this kind of thing. So as they think about their different strategies, in the past, if you think about it, our only strategy for an economy of scale was really pretty much to make to stock. Yes, we might do a little bit of sub-assemblies in advance, but mostly we're making to stock. The more we start to move into a uh, more economies of scope or a more variety, competing on variety, we've got to be able to configure to order. We've got to think about a different way of doing things. And in order to do that, we have to change really our relationship with our suppliers. We've got to share more information with them, particularly PLM information. We've got to collaborate more with them and perhaps also our channels by which we sell. Now, admittedly, there are some industries where this is easier than others. So some, for example, mill industries, I just got the example here of paper. I've been working with a paper company around this. It's very hard to do that because you have to make paper at scale. The same thing with steel. You can't really make yet a single ream or a single sheet of paper. So there are limitations about what you can do here. But the important thing is that this kind of mass customization enables you to rethink what your offer is, and it enables you to rethink lead time, price, options, that combination, which is critical in this idea of competing on variety. And one of the things that I talked about there, the idea of configure to order, it's really all about building modularity. So in our research, we've been working with people on using PLM data, but using order data, and that whole engineering technology to information technology where the orders are, to operational technology where they're executed, using all of that data to try and make a foundation for product line engineering. So, for example, we might share some elements between different specialized offerings. And when we change the design of one of them, we want to change the design of all of them and to automate that very important element of product line engineering support in PLM. So I mentioned the kind of the excitement of all of this, but I ought to say something about the challenges too. There's a massive challenges around managing supply chain and production synchronization. And I hinted at that when I said you're probably going to change the relationship with your suppliers. I'm probably going to get a lot closer to them and share more with them. Same probably with your channels or even your key customers. And if you think about something like a jet engine, manufacturers are not selling to OEMs like Airbus or Boeing. They're actually selling to the airline. And this will become more and more common in industrial manufacturing. What other challenges are there? Challenges around integrating legacy applications. I talked about MES and ERP there, but also around workforce empowerment. This kind of variety is challenging for a workforce, and you need to help them. They need to have the right work instructions, but perhaps more training and encouragement as well. I talked about synchronizing supply chain and production. We have a ton of research on this. One of the things that you've got to do is to establish a network in which you exchange the right kind of trusted data. And perhaps also there's a lot of interest in this idea of end-tier supply chain transparency. So in the past, we perhaps, in many manufacturers, we've just had a relationship with tier one suppliers, and they with their tier suppliers and so on to component suppliers. That really doesn't work anymore, particularly in a world where we've got the EU supply chain laws where you've got to be responsible to the nth level of your supply chain for the treatment of labor and the environment. And we see the same thing, some things like the Uyghur Forced Labor Protection Act in North America, or even the interest that people have in understanding what the carbon footprint of an item is and being able to explain that to their customers. So if you're interested in this, we have quite a lot of research on it. We've done three, I think, waves on this idea of a collaborative supply network. So how do you share this data up and down the supply network in order to make your to simplify the synchronization of your supply chain and your manufacturing. It's also true, we mentioned this already, that to do this kind of mass customization, to make this pivot to compete on variety, you've got to be able to link your manufacturing to your sales process. And that means exposing quite a lot of detail, and it might be, yeah, proper configuration, technical configuration to your Salesforce automation. So in the past, we've worked a lot with people around what they call configure price quote, often very, very simplistic, often just, a discount for buying two of the same thing or a discount for buying a basket or variety of choice. But increasingly, we're going to see much more, I would say, what used to be very laborious engineer to order becoming much more automated, maybe even self-service. I talked to somebody this morning in the HVAC business, and what they're able to do with their channels is to give them online access to a technical configurator so that they can provide that to building information management and to their contractors. And we'll see a lot more of that, and PLM will be the foundation for making that successful. What else are we going to see? We're going to see much more use of marketplaces. So we're going to see people in industrial manufacturing moving more to use marketplaces. At the moment, they're pretty simplistic. So they're really, I would say, selling selling consumable items. But once we move to more technical items, we're going to need to be able to expose that PLM data, exactly as my HVAC client did this morning, to for people to be able to configure and understand what does that mean for lead time, and for us to understand, do we have the capacity, do we have the material, do we have the people to do that? So we'll see a lot more of that. And in general, in our future of manufacturing, we look at three time horizons. So we look at the kind of current to 2 year period, which is the first block here, 2 years to 5 years in the second block, and 5 years to 7 years in the third block. And we're already, I think, in the era of thinking about reusability. This is very, very significant. So the materials that we're using need to be tagged and need to know what will be their cradle to grave, what will be their life cycle, where did they come from, how is the environment and labor treated, and when they're finished, what will happen to them, what will be their recycling. So particularly we see that also in North America around, for example, PFAS content and what will happen there. But in future, this will move further out to an age of mass customization, where perhaps the customers are going to have much more say in the materials and methods and the sourcing or origin of of the raw materials and the components that are in the manufactured items. So one thing that you might like to do offline is to think about where you are in this process. Are you just starting in your journey? Are you piloting some new approaches? Are you beginning to scale that mass customization, or are you already perhaps fully optimized? We've talked about some different technologies here. We talked about digital twins. We talked about PLM and configuration. We just touched briefly on AI and automation. And we also talked about supply chain optimization. Be interesting to know which of those you think offers most value. And then what do you think are the most biggest challenges? Is it around supply chain complexity? Is it around legacy system integration? Remember that pane of glass, or lubricating the linkage between PLM, ERP, MES, and maybe about manufacturing agility. So using new technologies like 3D technology or AI to reset and recalibrate machines so your changeover time is quicker than it was before. Or maybe the big challenge is around cost and profitability. We've seen some examples of manufacturers for whom ultimately they had to scale back the choice that they were offering. Well, I promised you that I would offer you some research that you might be interested in, and this is the research that I used to put together this short presentation. If you can't access it, please send me an email. I'll be happy to let you get hold of it. And with that, I'd like to say thank you and hand back to Josh.
Thanks so much, George. Excellent presentation. Super interesting topic. Hopefully, folks will engage online. We'd love to have a continued conversation. The polls that you saw, you would be please take the time to answer, and we will for certain comment on what the findings were, and perhaps have an online conversation about those as well. So just as closing, I'd like to just a little public announcement. Please join the ARIS community at our 25th anniversary event or user conference that runs during the first week of April here in my hometown in Boston, Mass. So please feel free to register. You can use the register code there in the slide here. And then finally, just if you hit the next slide, George, we have a few additional webinars as part of this series coming up. We've got in March another look at config to order, specifically looking at really more the industrial equipment space and kind of how, as you look at the massive complex industrial machinery, how these same principles that George has been talking about really are implemented from a PLM digital thread standpoint. And then finally, looking at another important topic, sustainability and beyond, really looking at the role of digital product passports and solutions to address emerging requirements in the EU and more broadly. So with that, I thank everyone for your participation, and please tune in next time. Thanks, George, for being with us.